Good morning. My name is Christina Fennell, and I'm going to explain the fitness problem for the bioinformatics midterm. So here I have a blank. Well, here is the actual answer that I had, but here is a blank version of it, of the question. So it states there are many single gene deletion mutants in yeast. Their growth fitness have been measured and provided in growthfitness.home.csv. In this file, which is what type of file? In this file, growth fitness are measured in different media, such as YPD, YPDGE, YPG, YPE, YPL, etc. So first it tells me to read the yeast growth fitness data. So I'm gonna make sure that our session and directory are properly selected. So at working directory, choose directory. Go to downloads where my material is, exam 1, go into fitness, and I select the yeast.fitness folder, so it should be fine. So I'm gonna first read this that would give it to me already. And then here it is, you can see that fitness is here with 2,706 variables. Here's the table of all, basically, everything. So we have that here, great. Now we can get to work. So the first question asks to find how many rows in fitness are in the fitness data frame. So I wanted to know using a function called nrow, so nrow, and then put in fitness, which is the file essentially. And I want to print that answer. And then in the console, it tells me there's 2,706 rows, and that's great because it's aligned with the observations in the variable. I'm sorry, in the data given to us. So next we want to show how many column names are for the data fitness data frame. So similarly, I went to the column names with the whole data to see what the answer is going to be. I'm going to run that, and here it lists the column names that you have. That's great. And then now it wants to know, show the codes to find out where the row of YAL007 C and the gene ERP2 are located. This is kind of tricky, but it worked out where I could first one give it a name. So row, I named it ERP2, in which I want to find out where fitness, I'm selecting to where fitness for the file is going to equal where ERP2, where that gene is located, and arrange it so it's going to equal true. So wherever in the file that ERP2 located is going to show where that is. And I want to print that too. Handy, oopsies. So first, I'm going to make sure this row works. And it does. You can see here, I went to my global environment, and it's kind of found it for me. And I print that out to make it more clear. So the row is in row 6 and call 2, wherever ERP2 is located. So next it says that, oh, I think something changed, but, oh, no, sorry, it's the same thing. I think I did listen by accident. That was me. And then next, the question wants to know, show the R codes to find out where the row or gene is equal to FET3. So this is similar to what we did before, where you want to find where it is located. So I'm going to put row and make it FET3 in the situation as my variable name, and then which fitness, the data is going to equal to, oopsies, equal to, in this case, is going to be FET3. And then arrange it so where they arrange individual Oopsie, I keep messing up. Comma equals true, and then I want to print that out because I want to see what the result is. So let's see how this works. And it's again here in the global environment, so I know that it's found. And then I'm going to highlight the variable so you print out the answer for me. And then there's row 1001 and column 2. And then show your R code to find the average value. And this is where you find the mean for it. So I want to find the mean of fitness YPD as given to me. And then I want to remove everything that has NA for the data because it's going to prevent me from finding the result. So that's what NA.rm is for. And then run that, and it gives me that the mean is 0.9736503. And then is there a correlation? So I want to make a plot essentially where YPD X, YPG's Y, and again I want to remove everything that says that's NA to have data. It's true. And that will give me this plot here. Oh, I'm sorry. There's some mistake made, and I want to fix it real fast. Let me think. Excuse me. Error and plot YPD. This YPD is not found, but maybe, let me think. YPD is listed here, so I know that's true. Oh, you know what? I know why. Excuse me. So again, before I can just use the variable, I have to make sure that all the NAs are removed. So I'm going to rename it YPD is going to equal NA.omit. I'm omitting all the NA information to make and select just for the YPD column, excluding the NA values. And then I'm going to do the same thing for YPG, and then I can make the plot properly. I apologize. So YPG, NA.omit, fitness. And again, I'm just selecting for that column. And the correlation portion of it. So there's a function called, correlation with core. So I can do YPD with YPG. And then that should be okay. And then you see that my YPG, D and YPG are here. And oopsies. Should make it, oops, I'm just messing up today. So like you see the correlation is 0.7054, which is a pretty moderately decent correlation. It would be stronger if it was closer to 1, but it is what it is. And so now we're making a figure. So this is where we can use a plot for YPD and YPG that we created. And I think it's a little bit of error due to some graphical parameters, but you can still plot the results here. And I'm going to make a line to further demonstrate that there is a form of correlation. And then put a title on it because I want to make sure that it's clear what I'm making the plot of. And then I'll make a summary if possible. so I can get more information. Let me see if that works. So here it is. So it's kind of small, move this over, but you can see the plot, and it gives information more about the residuals, coefficients, standard deviation, p-value. So it's more information. Usually these results are not significant, or are significant, excuse me. But here essentially how I solve this problem. Thank you.